guys bridge of data analysis. It's just a webinar. Let's get to understand what data analysis is. So I'm going to share my screen and start right away. So just give me a minute. Okay, so yeah, my name is Lawrence, Engineer Lawrence Akubu. I'm the managing director of KodeHauz. I hope um, I am audible. I just need someone to confirm. That's the first one. I just equally need someone to confirm that the slide is visible as well. With that, I am good to go. Okay, so this is a virtual webinar. We're going to talk about data analysis. I'm not going into anything, Excel, Tableau, or Power BI, but we're going to talk about data and the reason why, someone should even think about this. All right. So first of all, I'm going to, look at why data analysis, right? I want you to understand that you will hear a lot of things, data science, data analysis, this one, machine learning, AI, and all that. Okay. Data analytics, yeah, these are all the nomenclatures you're going to hear. But at least I want us to understand where all these things are coming from. Cast your mind back. I don't know how many of us had smartphone years back. Let me say 10 years, 20 years, 15 years. I can't remember having something like a 4G network in 20, let me say 2017. Um, I can't remember equally having cloud platform where I store stuff and I can, exchange it with other people. Now, what you people are experiencing is not something that happens in silos. Like data analysis does not just grow. Everything in technology, I want you to observe, everything in technology actually kind of grows together. And that is why today you're hearing AI. Okay, AI of today, is actually deeply rooted in data. But the AI of years back is rooted in mathematical principles. Now, there are a lot of okay, AI means artificial intelligence for those that probably were wondering. So there are a lot of paradigms of AI. You have expert systems, fuzzy logic and all that. So, but the one that is really the one that everybody knows that AI today is the AI that has to do with data, which specifically is called machine learning. So you begin to kind of delineate some of this nomenclature because we need to understand them so that you know what is happening in now, today. You know what is driving you towards even having an interest in data. It didn't happen naturally. Oh. All of us have ATM, right? I'm not sure that we had a meeting in our village and we decided to go and obtain our ATM card, right? It is things that were happening around you that led to it. And I'm going to tie into why some of us are beginning to even kind of develop interest in data analysis because these are all tied together. Now, when we had all our phones, you could exchange it over the internet. You knew that we grew from, of course, some people used Edge, then you have H plus, you have now 2G, 3G, 4G. Now, while the internet connectivity was improving, right, we are equally having a computing power in the smartphone also improving. We move from things like 1 gigram, 2 gigram, 3 gigram. So the processing that happens inside your phone was equally improving. Because if you are improving only the connectivity and the processor in your system is not fast and it cannot process data, it is not going to work. This whole thing is not going to work, right? Why that is happening also, the storage also was equally improving. So compute, the storage, and the network. These are the things that have given rise to what we have today. So you can call it whatever it is, right? It is the compute, it is the storage, and it is the network that has improved over the years. And why this thing is improving, of course, what is even actually improving? It is processing something, it is computing something, it is transmitting something, and it is transferring something. So what is that thing that is processed more, transferred more, and stored more? Ladies and gentlemen, the answer is simple. This four-letter word, data. Now, what has happened, let me, put the focus on the slide now, is 90% of the world data is generated in the last 2 years. Like from the beginning of man till today, 90% of the data was generated in just last 2 years. What does it tell us? The growth in data generation is exponential. It is not arithmetic. I don't want to go into mathematics, but let me explain in simple language the difference between, other kind of growth and exponential growth. Exponential growth means, okay, let me use arithmetic. If I have 1 today, I'll have 2 tomorrow, I'll have 4, the next day, then I'll have 8, then I'll have 16. So you can see how it's growing, right? So there is a pattern in that growth. Okay, so that is kind of arithmetic. You can represent it with an expression. They call it algebraic expression, but that's not what we are talking about today. Let me bring it into perspective what exponent is. Exponent means I have 1 today. All of a sudden, I have 5 tomorrow. From 5, I move to 100. The expectation is that probably I move from 100 to 200. Then I move from 100 to 10,000. Then I move from 10,000 to 10 million. I want to explain this first paragraph. They are telling you that so if you look at it, the line is like this, okay? So a huge amount of data is generated per second now than that was generated in 5 years, around maybe 4 decades from now, backwards. That's what we are trying to say. Now, if you check how many text messages you sent this year, you will notice that the number of text messages through WhatsApp and other social media platforms, okay, let me not say message, the text, the number of texts you have produced in terms of comments and all that, responding to this thing, if you kind of put the data across what you did 20 years ago, you will see that just today is equivalent to what you did like in 5 months. Just today is equivalent to what you did like 5 months, how many years ago? Because sometimes you texted only once and all that. So now we are going to have more than 2.7 zettabytes of data existing in the whole, in fact, we have it existing already, right? And it is projected to grow to 180 zettabytes. Zettabyte is 0.0000000000000. Like I am talking about the quantum of data that is generated. Okay, so what is the relevance of all this now I'm trying to explain, right? We now have cloud, you now have smartphone, a lot of things are generating data, exchanging information and all that. It has created a problem. One thing about technology is why you're trying to solve one, another problem comes out. The problem that has been created right now is that you need to draw insight from that. Therefore, look at the points in the blue there. The ability of anyone, whether you are in Africa, anyone that is existing anywhere in the world, right? the ability to extract meaningful insights from the vast amount of data. You see, I put it in blue. Ladies and gentlemen, has become crucial in businesses today to make informed decisions and optimize processes and identify opportunities for growth. That is why you are paid as a data analyst. So everything that is happening now is that the technology advancements and the trend has created a problem now. And the problem has created so much data. And now your ability to extract meaningful insights. And that act of extracting meaningful insight is what we are talking about today. So I want you to understand why data analysis. You understand? So you could see that it is no longer a leisure. It is now a necessity. There is no single organization, serious organization, that is not going to pay attention to that. Paying attention to that is not, oh, we need to. No, paying attention to that is a conscious effort to pay someone that will be able to take care of that. Please, I want you to Google top demand jobs in 2025, right? Just if you are using a phone, if you are using, because this is not a motivational, this is a webinar, right? This is real. So just Google it. You are going to see software development, health service management. I not say top tech skill job, I say just top skill job generally in the world. Financial management, you're going to see data science. You are going to see data analysis. So, ladies and gentlemen, we're having this webinar because somehow I'm not the first person that introduced the idea of data analysis in your mind. You have seen it somewhere, you have seen adverts, probably in your company you want to improve and all that. I am not the one that brought you here. It is your interest, it is your ambition, your curiosity that have brought you to this webinar, meaning that it is something that is happening in around you today. Just like somehow, like remember I kind of throw the joke about how all of us acquired ATM, whether we had a village meeting for no, it's things that were happening around us all of a sudden. You saw yourself, you have an ATM. If you remember, there was never a time you had any meeting, a family meeting, as everybody go and get your ATM. All of a sudden you have ATM. So you could see that data analysis has become one of the top jobs in the world. I'm not talking of Nigeria. I'm not talking of Africa. I'm talking about the world today. Now, what is even data, right? Please, data is simple. Don't need to overthink it, okay? Raw facts, figure, information collected from various sources. We're going to touch on all these things, fact, figures, sources. We are going to touch on sources, which can be processed. Remember, we are talking about IT here. We are not talking about healthcare or whatever. We are talking about IT. So when you talk about process, you're talking about a tool which has to do with a hardware and a software. And definitely we are going to end up with the software because that is what the analysis is all about. Then analyzed. So it has to be processed, it has to be analyzed, and used for what? Decision making. You see, the definition of data alone even shows you the functionalities of, remember I said the ability to do some things, you understand? Now, those things, to draw insight means processing, analyzing, and what? Using it to make decision, right? You can see it can exist in different forms, right? So we are going to come to all these things, we are not going to just browse through this and everything. Now, it is important that we talk about, the data and information. You see, we have been talking about drawing insight. When you talk about data, it is raw facts that are collected, is unorganized, without context, can be quantitative, can be qualitative, example is the number of people that visited a site today, individual customer survey response. What is the price of a product? Yeah, these things are information, right? But what can you use it for? Sorry, these things are data. What can you use it for, right? The digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is data. But if I arrange it in such a way, I say 0803795, 3631 and everything, it becomes somebody's phone number. That's the thing. So raw data information. And that person's phone number has to be processed. And if I make mistake in the process, also, it's going to create a problem. Assuming I store somebody else's number as, there are different errors. We are going to come to that. Information is when you have processed the insight you are able to draw. Of course, it gives you what? The results. And also, it gives you context and then can be used for decision making. These are example. If I say 20/80 blood pressure reading, what does that mean? It doesn't make any sense. But if I attach it to somebody, are you seeing it? Now, we are going to be talking about, what they call key pair. I'm not going to delve into data today, but I'm going to just go through it. You understand? Date of an employee application and employee application record. If I say 30th of June 2020, so that's the date of application now. But if I collect somebody's record, the record will contain the person that applied, the day the person applied, all the person's credentials will be there and everything. So you can see that is information. Number of cesarean operations that is done in a hospital, as against saying this particular hospital have this cesarean operation rates. Something like a vendor address and vendor's record. We are going to talk about record when we talk about database. Now, when we talk about data, two primary sources of data that whoever that calls himself an analyst must be dealing with is number one is the primary source, and it's number two is the secondary source. So having defined data, we are now talking about how do we even locate this data. So whatever you do as a data analyst, you must be getting your sources from the primary sources and the secondary sources. So for the primary sources, I want to make it very simple, right? Primary sources identified and collected directly yourself. Somebody had done the primary collection and you are referring to that data. So you are kind of collecting data from data that has already been collected. So if you look at this, these are the simple definition of it. It's not that simple, but I try to keep things simple. For instance, if you carry out you are the one carrying out experiments in the lab, so the reading that you get, you are the one writing it down. The concentration is so and so parts per million and all that. You write it down. You make an observation of temperature so degree, a patient, so if you are the one writing these things down, it is primary source. If I go and interview people, I am getting information that's what they call the horse's mouth. So it is primary source. If I'm making an observation, just like Isaac Newton, and the Galileo and all those that kind of started studying stars, trying to look at the galaxies and stuff like that, and keeping records of how they were glowing, how they calculated the light years, and how they were able to observe the sun is moving around the earth is moving around the sun, and all those kind. They are the ones collecting it. They can now put it in a literature, and someone else will now go and refer to it. Share those questionnaires. You share questionnaire, people answer. Now you are going to be dealing with it too, right? But as an analyst, I promise you are going to be dealing more with secondary sources of data. Data has already been collected. They will call you in to come and, look at it. Government data, organizational data, official documents, statistical record, books. So you asked to collect data yourself, and when you are asked to analyze data. So having mentioned, depending on the way the data comes to you, it has to pass through a process, right? If you have a primary data, the pipeline is going to be different, right? Because in the primary thing, you are the one that will develop a hypothesis. Forget this grammar. Hypothesis, you guys say, okay, I want to that particular entity make a certain assumption. For instance, in my community, whether that truth that you want to find out, you declare a hypothesis. So in primary data, you kind of have that hypothesis in your head, and then you go ahead and collect data that will help you kind of analyze and visualize it. Now, if it is secondary, go to the third one. I'll come back to the middle one later. If it is secondary data, you first of all collect the data first, right? When you collect the data, then you kind of say, okay, let me study this information and find out something. So the collection comes before what? The hypothesis. So I want you to understand the mind of a data analyst. It begins from here. It is not by software. A lot of people think that, when you talk about data, it's all about downloading Excel, importing files, blah, blah, blah. No, there's what they call the data analysis mindset. And if you listen to this webinar, you understand it very, very well. So you have to have a mindset of, so even from the job that you are giving, even from what they ask you to do, you already know the kind of thing where you are coming in. So assuming somebody wants you to look at the COVID-19 record or something like that, it's already been collected. You don't ask yourself, you need to go back to the person, look at the record, what do you want? You understand? That asking of the question, what do you want? You are trying to actually understand the hypothesis the person wants, because data has already been collected. You are not going to start asking the person what we want. You cannot kind of propose a hypothesis, then trying to collect data. So what happens is that you get the data and say, okay, this is what we want to get from the data. You now dig in. And digging in, this is where now the tools that we are going to study will help you, because I can assure you guys, anybody that is calling you in as a data analyst has already seen that the job is going to be difficult for him or her, any organization. So don't think that this whole idea of data is just is like a bread and butter. No, it's already difficult. That's why they are calling you. So you are the one that will dive deep and kind of create some. So I want you to know, in certain situation, you will be the one that will create hypothesis and then come with the result and display the visualization and make a presentation. Now let's go to the one in the middle. That there are situations that will require you to do a hybrid. A hybrid is kind of a combination of primary data and secondary data. In that case, there's going to be collection before and after the hypothesis. It's not going to be straightforward, because I'll give you an example. Okay, there is an observation that has already been made, and there is a new population somebody wants you to study. What you need to do, you need to understand the pattern in the existing observation that has been done. Example, there is this thing, anybody that coughs and the sound of the cough is so and so and so, you understand. We kind of studied and found out that there are like 3 of different kind of this thing, sit down and everything. So formation and study it. With that, now we stay in the lab, stay in your room, do a lot of research and analysis, come up with your information, and they now tell you, okay, You're not going to Ogun State. There is a community in Ogun State that so and so. It's okay, no problem. Now, in that case, now you can see you don't have the Ogun State data. We are going to study the same thing. You cannot say, no, don't worry, I don't need to go there, sir. Come, let me teach you what I saw in the data that you gave me. It means you are not really a very good data analyst. Existing this thing. Then go to the sample. You know, these terms I'm using, I'm just using normal, but what I'm talking about is sample and population. You go to the sample, and then you'll be able to use the already existing inference from the hypothesis, collect more information, and then go back and see if there is a match between. So in this case, there is hybrid. You are collecting direct information yourself, and that's the primary data collection. You can see, so data collection happens before and after. Then everything, ladies and gentlemen, if you do all these things without presenting it, that is why all the arrow goes to visualization. We started by saying the ability to what? I'll keep on repeating this now until the end of the idea of data analysis is decision. Anybody should not deceive you. The end of data analysis is decision making. You understand? So now there's going to be, you know, all these things I'm talking about. It's not like you're going to Ogun State, blah blah blah. When it comes to IT, guys, you're going to get data from different kinds of very, very wet sources. And this is real. What you are seeing in this slide is exactly what you are going to meet in the IT world. You understand? People are going to give you information, give you a key to log into Amazon, RDS, you know, there are data, you know, there are different databases in this thing. MySQL, Windows Server, Oracle, Salesforce, Hadoop, you know, BigQuery, and all that, Excel, and blah, 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 blah. There is going to be, in fact, I'm going to show you a slide that I have. This is, of course, if you join the course that is going to follow this, you're going to follow me and do some of this. This is Power BI. I'm going to go through 4 slides, and you're going to see, man, when we talk about data science, sorry, not even the devil can collect data. Some things you have never heard before. This slide is filled up. I'm not sure how many of us on this call know 1/5 of the names on this slide. Okay. This one again. These are data sources. Ladies and gentlemen, this is the real. Like I said, this is not motivational. This is the real. These are more. I don't know how many of you are even familiar with like 1/2 or 1/10 of everything that is here. What I am telling you at the beginning is real. There are many people developing many databases, all of you know Oracle, BigQuery. There are many of them. Then, like I said, as a data analyst, some people will send you to the devil to go and collect data. That is real. And this is something that's going to be happening. You can see there are more of them. Okay. I just kind of screen grab this thing from what Power BI. You know, these are data sources that Power BI can link. So whether it is primary data, secondary data, remember, nobody's going to come and give you an exam and say, name 2 sources of data. That one is done in universities. Number 1, and that's the kind of education we pass through. You write the exam and you answer script and pass. All this, no, I'm not. That's everything I've said now is for us to know. Nobody's going to say define primary data source, define secondary data source. That's not what you're going to be doing as a data analyst. Okay. So having said that, so some of these things I'm giving is a theoretical background so that you understand some of these things. There are different sampling methods because everything I'm doing now is about data sources. You understand? I'm sure that before this webinar is to run from 6 to 8. So I'm going to ensure that before like 7:30 will have been done, so that probably you can take answers and question and answers, and sorry, you can take questions, and then so by my time now is 6:36. So I'll be conscious of the time. All right, let's continue. Now, sampling method. So these are things that, again, please, I'm not trying to do these things so that you cram anything here. Oh, primary, secondary, I know we are already used to all those. No, this thing is for you to just, okay, like understand it, and just like nobody's going to wake you up one day and say, give me two sampling method and blah, blah. This thing is done in Maths and Statistics University. You understand? So please, what I'm going to go through now is the process. So I don't want anybody that is going through our data analysis, this thing, nobody's going to see. Go and check YouTube, anywhere, Coursera. I can assure you, I'm basic fundamentals. So you need to understand some of these things. Please confirm that you can still hear. I'm seeing some network error on my screen. Can I still be heard? Okay, thank you. All right, so let's go to sampling. Every data you have seen has been sampled, though, right? They have passed through any of this method that you have seen on this screen, right? There's what they call probabilistic sampling method and non-probabilistic sampling method. Okay, so sampling is the idea that you cannot cover everything, but you can take a representative of that thing and try and see if you can define that thing. Sorry, it's kind of confusing and it's kind of what's it called? But let me explain. Let me say I want to study poor people in Nigeria, right? Example. It would be stupid of me to think that I can speak to every single poor person in Nigeria. You can see where the idea of sampling. See, if you remove sampling in data analysis, sorry for you. It means that you don't even know what you are doing. So, because I cannot speak with every poor person in Nigeria to understand their flights and everything, because we have 36 states, I cannot, in my lifetime, if that is a PhD, I will never get that PhD till I die. Because I'll be moving from one local government. Of course, you people know that it's only a mad person that will even attempt to do that. Because if I am in a local government today, what makes me think that the person I'm talking to will not move to the local government I'm going to move to? So it is definitely impossible. So there is no data science or data analysis without sampling. The reason why DeepSeek and ChatGPT is working is because they trained data. They did not train all possible data. They trained a sample and used a sample to develop an algorithm, and the algorithm is now, there's what they call inductive and deductive. Well, let's not just go into all those things. Let's take it easy first of all. Let me go back to sampling, please, because before you know it now, I will veer off. Now, there is a population that it is impossible for you to like touch everything, and that population is the population of your interests. But there's no way you can touch every single nook and cranny of our population. So what you are going to do is what they call sampling. Sampling simply means I'm going to take a part of that population to see if I study that part of that population, would it be able to kind of define what that population looks like? You can see that you can't really say you are doing data analysis without really sampling. You understand? So you see, it doesn't really come out like that, when you are doing all this Excel thing and blah, blah, blah. But you're going to see, what I'm trying to do now is for you to, I'm trying to create that data analysis brain. You understand? That data analysis mind. That's what this webinar is all about. So that when we go into, you carry Excel clicking and, writing formulas and So you understand what you are doing. So when I talk about this and that, so you, okay, this is making sense. So that's what we are trying to do here. Make it very simple for people to understand. Not so much theoretical this thing, So now let us go to probabilistic and non-probabilistic, right? I'm going to explain to you why it is called probability. Why people know probability, right? The chance that something will, if you throw a coin, what is the chance that your head will come out and that? What is the chance? So let me use that word, chance. Okay. So in the probability sampling, okay, there is the idea, okay, there is the concept of chance, okay, of the population with of the sample ratio to the population. Okay, there is a chance. Okay, but in the non-probabilistic method, the concept of chance is not there. So I want to use chance to make it very simple for you to understand, because if I use the technical term to define it, you'll be like, so what have you said? And that's what is wrong with our education, because sometimes the technical term does not even confuses you more. And this is probability when a sample is taken and blah blah blah. When there is this thing, so it's a chance. Please, let's take it that way. And you are going to see the reason why. Okay, let's go to the simple random sampling. I'm going to be using chance in all this definition so you understand. A simple random selection, right? You have actually mapped out a sample by giving chance randomly. So I'll give you an example. I come into a room, okay, a classroom. Let me use a classroom. I have, boys and girls there, right? And I say, the teacher say, people, we do this a lot in secondary school. A teacher will ask a prefect, please get me 10 people from JS1A. You see, it is not specific 10 people. Those 10 people are sample. I want you to understand that we have actually been practicing this thing. Those 10 people are sample. But what happens is that the person will now go without any criteria and randomly select 10 people. Now, why is it probabilistic? It's probabilistic because there are specific number of people in that class. So if that class is made up of 50 people, if I'm going to select people, whether I am selecting them randomly, the chance that one person is selected is 10/50, even though it is random. That is the idea of random sampling. So I want you to, let me tell this story now. It's no longer teacher. Say, go and sample 10 people from a population. Now, those 10 people are going to be, okay, you 1, 2, 3, you. Auntie, okay, no, we are already 10. Don't worry, go. Probably they want to go, and some people like leaving the class. I remember that I went there. I just, anything that will take me out of it, even if it is work, as far as I'm not where others are, I want to join. So something like that would be, but probably if we fetch water, they can give us probably biscuit and we can eat or something like that. So you could see, if the 11th person wants to say, no, sorry, we are 10 already, go back. You understand? So what it means is that if you throw back those 10 people and you want to select again, if you are selecting exactly 10, you might not select those first 10 again, but the fact still remains that every single person in that class has 1/50% chance of being picked. That's the idea of random sampling. Okay? Stratified sampling, right, is the fact that I'm going to use the same classroom again. You're going back to that classroom. Okay? Now, you're not, yes, you still need 10 people, but now I'm specifying, give me 10 boys, and give me 5 boys and give me 5 girls. So what happens in that case now is that I am going to stratify the class into girls and boys. Because if I do random, the other random I didn't care. I can end up with 6 guys and 4 girls, four girls and 6 guys and everything. It doesn't matter. But in the stratified now, you will see that before picking, I will stratify them. That's the idea. I will divide them into 2. The boys this way, the girls this way. Do you know why? Because in that class of 50, the boys might be 30 and the girls might be what? 20. Right? Now, I have divided it into 2. If I go to the place where the boys are 20, sorry, I don't remember, whoever is 20, and I want to take 5, each of them has 5/20 chance of being picked. And then the other side was again have what? 5/30. Are you seeing it? 5/20, 5/30. Because it is stratified. Because at the end of the day, what I want is 5 from here and 5 from here. And then I'll get my 10. Let's go to cluster. Cluster is a random, a probability sampling that just divides, okay? That just divides into cluster. Now, cluster is just cluster. Cluster is more of spatial. Example, I can come to that class and say, do you know what? If you are this side, move this way. If you are to my left, move this way. I divided it into cluster. I don't care how many boys is on the left side of the class and how many girls is on the left side of the class. I'll just split them in that way, and I will say I want 5 from here, I want 5 from here. So we are sampling a cluster. You understand? So that is cluster. Sometimes people misunderstand stratified and cluster. The difference between stratified and cluster, there is a specific criteria in such a way that the makeup of the stratas give them homogeneity. You understand? For you to now sample. But in cluster, you don't necessarily need to move for go for homogeneity. You're just dividing. For instance, people want to take sample in Nigeria and I'll divide it north, west, east, and I don't care. That is cluster. You understand? Then systematic, that is the last bit of probabilistic sampling. The systematic is in such a way that, how many of you have seen a place where I want to divide a class like this and I came up with an idea. I said, okay, the way I'm going to do this, I say, you take number 1, 2, 3, 4. So we're going to take one. If you reach 4, you start from 1 again. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I'll keep on giving every 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. When I reach the end of the class, I will say, if you have the number 2, come out and follow me. You see, now what I have done is systematic. I have given them number because I don't want to come and be like this thing. Or another way of doing this thing, I can put a couple of numbers and everything, and then tell them to go and pick from a basket. In that basket, there are equal number of 1, 2, 3, 4s. So everybody will go and pick and pick and pick and pick and pick and pick, After pick and say, if you have picked number to follow me, it's the same thing. It's a systematic way. Now, what I've done is that everybody has a chance, because I didn't say, okay, this is how I'm going to pick. So people went and picked everything. You can see everything I've mentioned here is talking about chance, 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 chance. So that is probabilistic what? Sampling. Now let us go to non-probabilistic sampling. Similar to random sampling, there's what they call convenience sampling. Some people misunderstand or misinterpret random sampling to convenience sampling. They are not the same. Convenience is like, if I give you a questionnaire now, you enter the road, anybody you see, is random, right? But there's nothing like chance there. You understand? Anybody where you see, oh boy, I beg, help me fill this questionnaire. Family and friends is random. But please, don't call that random sampling. Don't call that random sampling. The actual thing you are doing is convenience sampling, right? So that's it. Two is quota system, right? Of course, everybody knows quota in Nigeria, right? You say, okay, do you know what? I am going to give geopolitical zones, da 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 da. So you see, there is not by chance. Okay, they have a quota. You have to fulfill that quota, and I have to sample from each of the geopolitical zone. All those kind of things. It is non-probabilistic sampling. Snowball sampling. Please, I want you to pay attention to this one. It's kind of confusing, but some of us that are doing special work, we have to pay attention here. People use snowball sampling when it is difficult to get to the target population. Again, let me repeat. When it is difficult to get to the target population, you resort to snowball sampling. Example, if I tell any of you here to get me, I want to study a population of boys that smoke Igbo in Nigeria. I don't think I don't think you can go to the streets and use convenience. You cannot use quota. What you are going to use is snowball. And what is snowball? Snowball is that you begin to snowball, dig deep into where you can find this. For instance, if I talk about cultists now, I want to interview cultists. One thing that can come to our mind is, okay, can somebody type in the chat, where do you people think I can find cultists in Nigeria? I think young people like cultists in Nigeria. Let me look at the charts. Who can tell me? Somebody say Road. University, God bless you. University. Thank you. University, secondary school, university, secondary school. Yeah, you see, now that's the thing. If you want to study that particular difficult situation, you cannot just go. You have to now snowball. Either you choose secondary school cultists or you choose university cultists, and probably someone say Riverine. I hear you. Well, it is still snowballing. If you feel that there are cultists in Riverine, go to Riverine, it's fine. But I can say, okay, let me go to university. See, going to the university, you have chosen university, you are snowballing now. Are you seeing it? Now, let me ask a further question. Is it private university or secondary? I say secondary. Is it private university or public university? Or your answer in the chat. Public, okay. Ade to Miwa say public. Public. Oh. Somebody put O. Okay. Private and public. Okay, someone say private and public. Now, you see, this is nose diving. Now, let me ask you people, is it all public university that you want to go? Where do you want to? I just want to sample. Like, I'm now doing sampling now. Which universities in the public university do people suggest? Let me see the answers. University of Calabar, Univen. Just continue. Uniben, Crutech, Unical. Unical has appeared twice. Unical has appeared 3 times, 4 times. Unilag has appeared twice. Unilag has appeared 3 times. Continue. UST. Okay. Uniport. Uniport is appearing for Unilag. Okay, now you can see that if I take the answer people have given here and I want to narrow down to only 3 schools, people have given me the answer. So what we have done here practically is snowballing. Okay, we came from where we study. We say university. Okay, is it private or public? We say public. You see, it is like a decision tree. So we are snowballing into where you can actually do, and you can say this will represent the population. You understand? So you could see that snowballing, even though it's not random, it's not probabilistic, but it's equally important. So what I'm trying to say now is that there is no disadvantage if you want to use probability sampling method in this particular case of cultists, you fail. You will not get anything. You will not come up with any results. Because, you probabilistic is giving a chance. brother, you are going to fail. That's the truth. So you could see that when it comes to sampling, sometimes I'm going to make this statement at the end. So judgmental sampling is where you kind of the person that is making the study kind of determines where he wants to go based on a particular what kind of list of you know features the person is looking for. I can say, okay, I want to do this. Is not like is more connected to snowballing, but it's judgmental in the sense that it is actually the person that is carrying out the sample that's okay, this is what I'm going to do and everything. So I want to study this particular thing in this particular area and everything. So I'm going to create a sample, probably environmental thing that has to do with oil and gas spillage and everything and everything. So you could see most of the data you're going to see, whether it's already collected or not collected, you could see that these are the things you're going to be experiencing already collected, and you see that some of the collections have already taken this method, and then you have that eye to understand, okay, so when you're even looking at your data, you understand, when you're even scanning through your data, let this thing, because is that this is the data analysis itself. It determines, nobody should, okay, the call is recorded. In case you don't probably understand all the sampling method, blah, 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 is recorded. You can actually refer to it and probably go through it again. Now, when data is collected, right, we are now moving on. This is the data lifecycle, because the mindset I'm trying to create is the mindset of data analysts. So we are moving on. Okay, well, the data has been collected. It can either come in as structured data or unstructured data. So structured data is the kind of data you find in the databases, right? Because it can be arranged in rows and columns. Trust me, as a data analyst, you're going to be dealing with rows and column data, but unstructured data. Because sometimes they could tell you to analyze what? Text. They are going to tell you to use LLM, large language model, to analyze, this thing you have to click. In fact, anyway, let me not go there first. So unstructured data. So what is structured data? What is unstructured data? Now, structured data can be displayed in rows and columns. It's usually numbers, dates, strings, estimates, requires less storage because it's stored in rows and columns and everything, easier managed and product. But unstructured data, you cannot display it in rows and columns. For instance, text messages. The text, my voice and everything cannot be put in a table. Images, it requires, of course, whenever you're recording audio, video files, and I know that it requires even text messages. They usually consume more storage spaces than other these things. So that is this thing. Now, but in between, also I want to mention there are semi-structured data. For instance, email addresses, they contain structure and they contain unstructured. So I want you to begin to understand there's what they call meta data. Meta, like Facebook meta. So when things come to you, there are the information, like for instance, if you get a music video, there is a metadata in that music video. And that's how somebody can claim his music catalog and all those kind, because there are some digital imprints in that thing that identifies what certain features of that particular digital asset, and that's what they call metadata. For instance, if you buy something like a generator, if you look at it, it will tell you the temperature is going to run, the make, the market that is made for, and all those things are codified, maybe in series of numbers or even model, like a model or a serial number of a particular product and everything. See, all those things can be stored in a table, right? It can be stored in a table, but there are some other parts of, for instance, the music itself cannot be stored in a table. So things can have a combination of both. So why this slide is to tell you that it is not a brick wall between structured data and unstructured. Is not true. There are some things that you have to combine, structured and unstructured. It's called semi-unstructured data. Okay, so I just want to please, I'm not teaching data structure now and all that. So let's talk about structured data now. Please, most of us, we are going to be dealing with this thing. There are two major data types, especially when you're talking about structured data. There's categorical and there's numerical. Categorical is further divided into nominal and ordinal. Numerical is very interval and ratio. Now I'm going to talk about nominal. When you talk about nominal data, you're talking about identity. It's categories. For instance, if you come to that class of 50 I'm talking about, what differentiates the 50 of us? Who can tell me what differentiates 50 of us in that 50 class, in the class of 50? Just type it in this thing. What differentiates us? I'm looking at the charts. Just an answer. Our names. Thank you very much. Somebody say our gender. Fine. Good. Names, gender, and all that. Ages. Good. Our personalities. Nice. Our looks. Fantastic. Okay, you can see now that I'm going to use in each of these to talk about this category. Now, our names. Okay. Somebody said names. In the class, the name is the primary differentiating factor, because they are going to make sure that all of us does not bear the same name, so that your result will go to you. When they are referring to you, even if it is John Okeke, they will put something to differentiate the two John Okeke. If they are John Okeke O and John Okeke A, they have to differentiate it. So that's what they call nominal. Norm is is a Latin word, but well, let's leave that one. Nominal. So nominal is categorizing to specificity, so that you don't have to combine, like it identifies you uniquely, right? Ordinal, right? If you look at things like um ordinal is equally like categorical. Can I use age? No, I can't use age for ordinal. Personality, I can't use it for ordinal. Looks, I can't use for our blood group. No, I can't use for ordinal. So, okay, blood group is a good example, because you have no blood group is nominal. Blood group is nominal. I'm going to tell you. In fact, let me tell you what differentiates nominal and ordinal, so we don't have to go into it. Ordinal is equally categorical, but in that case, there is a kind of pseudo graduation. What do I mean pseudo graduation? Like example, short, average, and tall. You can see I want short people, average people, and tall people. You can see that's categorical, but in this case, it is equally somehow differentiating and separating based on a certain criteria. So in names, there's no criteria. Name is name. You understand? There's no criteria. But when you come to ordinal, there's a criteria. Let me go to the next slide to just show you what I mean, right? So look at it. Lawrence is nominal. His average height, it's ordinal, because there are people that are middle height, you got tall people, short people, like what I'm average, you understand? So you can see that average somehow has differentiated me, but I am in the middle. So you can see that there is some form of categorization and graduation. So interval, I am among the 10 KodeHauz staff. So now, interval, I want to talk about integral. Integral is the whole number, like you cannot divide it, right? So, a human being, there's nothing like 1.5 of us or 1 point. It's okay, yeah, let me use decimal. You cannot say 1.3 of the 1.3 human beings. Is that you are dead or you are alive? you cannot be half. You understand? Even if you are in coma, you are still not dead. So population, something like that, they are. So ratio is this decimal because there's what they call accuracy, you understand, and precision. So we are going to come to that. Let go below, you can see nominal is equal in Nigeria. Nigeria is Nigeria. I'm born in Nigeria. You know, Nigeria is nominal differentiator, is their identity. There's nothing I can do to change it. But when I use the word developing country, I have graduated it because there is underdeveloped, there is developing, and there is developed. So in that context now, using that term developed, you understand? Then when it comes to population, 200 million people, you not say 200 million point five or some, okay, 200 million something, 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 point something. No. Now, GDP, you can say our GDP as of today is 36.85. That 0.85 years is a ratio. So then something like a West Africa is equally nominal. So look at this now. Example. Okay. So you could see nominal example. I just used the same example I gave. Nigeria is a country. And why is it nominal? It's because it's one of the countries in Africa. So when I say West Africa, why is it nominal? It's one of the four. You have West, you have North, okay, you have Eastern Africa, you have South Africa. Now, look at this thing. You can see that the color in the first two is different from the color in the third one, where you have dark green, lighter green, and all that. You can see that there's constant out of graduation. There's developing, and all that. You can see that. So this is the data analysis mindset of representing information. Okay. Now look at population. Now, when it comes to numerical, most of the time you can see you must not even really represent it in a what map, right? You could see the colors are in the one below, then the flags are close to what the numbers there. I can put the number without the flag itself and put the name of the country and put their population in there. This is the mindset of data analyst. So you begin to know, okay, representation is one of these, because at the end of the day, you're going to be giving information. Now let us go to GDP. You can see it is represented. Now you show both the map, you show both the color, because you need to equally show the graduation between when something is moving from yellow, whatever it represents, to green. I'm not here to teach Africa this thing, but you have to equally put the number, because it is what it is, a ratio. A ratio is simply means, I'm going to talk about it. There is scale value. Some people use graduation scale and everything to represent it, but this is what I'm talking about, right? So if you go back to this slide, you know, we have categorical and what numerical. On that categorical, you're going to have nominal and what ordinal. You know, then you have interval. For numerical, you have integral and you have ratio. So this is what you're talking about. Now, as a data analyst, how many information can you represent? I'm now going to show you different representation, and this representation is what is called in data science visualization. All your work should be ending in something like this, where you use pictures. What you are going to be giving is data. What you are going to be providing is visualization. Please, I want you people to know that today. You'll be provided data. Your job, whatever you are doing at the end of the day, is to provide a picture. And that picture is what we call the insight from that data. So you can see, I'm going to show you different, I'm not going to go into it. You see, there's what they call population density. It is showing you the graduation. There's called this thing a legend. You can see it starts from the lighter one to the darker one. Then you go, so that it tells you, when you look at the legend, you look at the map, you see where things are. This is one. We are going to do all these things in Power BI. You know, this is another one. Okay, two things represents here. They are showing you, if you look at the legend also, you see that, okay, teens, 20s, and 30s. What is this helping you to do? In order not to start confusing yourself, everywhere in green, it means that their average population teen. Everywhere there is yellow, the average population people are in 20. Everywhere you can see it creates that immediate information. So it is who does this? You are the one that will do this. Does the data come this way? No. So data analysts must also be creative in a way you represent information. So that's why I said you have to have that what data analysis mindset. This is another one, another visualization. You can see what is it telling? Who can read and write? They're now using colors, right, to represent 50% population of people can read and write. You can see if they use only color, it is not going to what cut it for them. They have to add the number so that you can equally read it. So what this particular one is showing you that sometimes color graduation is not enough. You need to impose the number. This one, you can see this one is using different color. This one is using color graduation. You see, this one did not have a scale. So a kind of legend that has scaling. This one has legend that has scaling from lighter to darker green and everything, and equally add the number to lay emphasis on it. Okay, see this one. Now, another concept that a data analyst should learn today is the concept of what we call what infographics, where you are inputting graphics into the information. This person uses smiley emoji and everything, even though it doesn't make sense to me, but I just had to put it. Literacy rates of African countries. I'm already getting overwhelmed. Can I do all these things? You know, at some point, you need to ask this question. Yes, as an analyst. Okay. That is why you will get paid to take away this stress from your clients. And who is your client? If your clients are the lazy people, either the person is lazy or the person is busy. Either of them collect their money. It's as simple as that. Okay. So recall, finally, I'm going to end this side with this. You have categorical, numerical. Categorical, you have nominal and ordinal. In nominal, you have dichotomous. Dichotomous is somebody talked about sex. It is two, male and female. Okay, polytomous is like Nigeria is one of the countries, I think it's 50 something, you know, so it is more than one, you understand? So I want to just put that. Now, under numerical, instead of using the other term, there's what they call discrete. That is integer. You cannot divide it into two. A human being is a human being, you know, number of students in a class. So continuous data is the same thing as ratio, is the same thing as scale. These are some of the facts they are going to see. So some other people come up with different data types and everything. They are similar. Anyone you come across, it has been explained. So then for those that are going to be doing programming, you are going to equal because you are going to be developing these softwares through which this data will come in, and you have to define it as well. So it might do you well. You can see Java. They have primitive and non-primitive. Please, we are not here for data type class. This is just a webinar. Everything in this webinar, apart from everything in this webinar is just for you to know what exists. You know. Now let us go to again. You know, we are on a journey. Like we have collected this structured data, and the type of data wherever they are. Then what is the database? Okay, whether it is structure or unstructured, whether it's coming from POS or email and everything, this thing is going to a place called database. Now, a simple database, this is what we call a relational database, but I think it defines database. Database is made up of fields and records. Every data analyst must understand fields and records. Okay? And I'm going to explain it so that when you see it tomorrow, how many fields, how many records are English? I'm going to explain it in simple terms. If I'm collecting information, okay, and the information I want to collect is, look at this. I have employee ID, first name, last name, title, date of birth, and address ID. That's 1, 2, 3, 4, 5 things, right? there are the fields. Okay, there are the fields. So if I give you a form, each of the things that required an entry in that form is a field. So if you remember that one, you are good to go. You don't need the definition of a field. If I give you a form, let me repeat. Anything that requires your interest, you need to put your first name. That thing, first name, is a field. That thing, second name, is a field. Your age, your sex, this, all those things are fields. Okay. Now, when you collect your form and first name, you start writing Anderson. Okay. That Anderson is a field value. You go to number 2. Okay. Okay, which is the surname, is the field value number 2. Male, gender, bisex. You put male. That is the field value number 3 in that form. Address, number, citizen. When you finish, okay, and you submit that form, what you are submitting is your record. Okay, you are submitting your record. So you have the field values. A collection of the field value for a particular entry is called a record. So that is the labeling that you are seeing in this slide. So you see the fields employee. So here we have how many fields? 1, 2, 3, 4, 5, 6. How many records do we have? 1, 2, 3, 4, 5, 6, 7. We have 7 records. Okay. And these records are made up of values. So that is what you need to understand. Now, let us go to relational database. It is made up of fields, records, and values. Why is it relational? Pay attention to this. Let me explain. It is relational because the first table kind of links to the second one. Now, there's what they call primary field, right? I've talked about field. So when I say primary field, you shouldn't be confused here. So the first table, if you pay attention to it, the primary field is the transaction ID, because each transaction ID will have a customer ID, you have a product ID, and have a purchase date, right? Now, pay attention to the second table. In that second table now, the primary field there now is the product ID, not the transaction ID. So the product ID has what? The product name and the price packaging. Look at the third one. So the third one also, has customer ID as the primary key. So how are these things related? Look at the colors of the primary key in the second and the third one, and look at the colors where they are represented in the main table. Ladies and gentlemen, let me explain to you what is happening here. This is for database operations. If you are someone that takes record, let me use the bank for instance. I think bank will explain this thing. All of us are opening accounts. First name, current account, savings account, current account, savings account, current account, savings account, current savings, current, saving, current. So this thing is the main database, right? Now, assuming I want to query, please, I'm using the technical terms now. Query means trying to request for information from a database. If I want to query that database, look at how difficult it will be. Remember, in this database that we are storing people's name in the bank, let me now say that your first and last, your name, okay, your bank number, your account number is the primary key, and we have a large input that you have your phone number, everything, right? Now, there is a column in that particular major database, you know, there's a column in that particular database that says whether it's the current account, type of account, right? Now, what it means is that, do you know that I can create another table where the primary key will be account type? So in the account type now, I will have all current account listing. That will have a table. All savings account, I'll have a table. What it means is that if I am to query, you understand, it makes sense for the database software to first of all find out what type of account am I looking for. It will direct me to a smaller table for me to get that information rather than sending me to the main table where I'm going to query everything before maybe my number is in last probably 1 million. You understand? So that is the sense behind this relational database. So what it means is that, as your data keeps growing, you need to have this thing. But let me now shock you. At some point, this is what you are going to have. And that is when you begin to get error in your banking apps and everything. Somehow, relational database has its advantage and equally has its disadvantage. By the time the data models get complicated, it's going to slow the system down. So you're going to have what? Non-relational database, right? It's more flexible, more scalable. What happens here is that instead of building it vertically, it splits it horizontally. It's going to use a key value to do that. So it tears it into servers, and each server will have what? A key and a hash that will help you to locate that information. Now, this is an example of the kind of thing. It is schemaless, in Jumia. This is the kind of thing you get. There are different, you sell bag of rice in Jumia, you still sell Milo in Jumia, you still sell TV in Jumia. Do they come with exactly the same information that can be stored in a table? The answer is no. So what happens is that you cannot use a relational database for those kind of things. You have to create a what? A non-relational database. I'm not going to go into database structure now, but I want you to understand the reason why some of these things exist. So the language that is used to query a structured database is what they call SQL. So structure query language. You're going to hear some of these things, okay? But the language you are going to use to query a non-relational database is no SQL databases. So these are the kind of databases you are going to use. Databases for structured and databases for unstructured. Now, so what are you querying? You are going to draw the data. Finally, we are ending today. We are coming to the meat of the matter. We have moved from the sources, so secondary, primary, database, and everything. We are now landed to data analysis. What is it? A lot of people, data scientists, data engineer, data analyst, and everything. Please let me differentiate it in the next 5 minutes. So data engineer, right? Whenever you hear something like this, it involves designing, building, and maintaining, the infrastructure required to support data processing and analysis. Infrastructure, whether it is the cloud, whether it is the server, the person that is building the infrastructure is the engineer. I want people to understand. And by extension, most of the time also includes what? Managing the database as well. Because if you manage the database, you know how to what? Restructure it if the structure that is existing is not working. So a lot of people that are going into cloud, this is things that you are going to pay attention to, but this is not a cloud class, but it is fine that I mentioned it. So those that, people will not be missing these nomenclatures together. Again, data engineer involves building, designing, and maintaining the infrastructure that is required to support data processing and analysis. They help you to build, some of the platform configure it. Some platform come out as a SaaS, software as a service, platform as a service. They equally render infrastructure as a service, IaaS, and all that. This is not a class for it, it's beyond this class. Data scientists, because people say, data science, data analysis, data science, data, they are not the same thing. A data scientist, right, is person like is broad because the activity includes what, improving the algorithm and the model that is used for processing, analyzing the data itself. So you are interested in the algorithm, the data structure. You are interested in improving the algorithm, the machine learning, the statistical model, the mathematics involved. So data scientist is a more serious thing. It takes time. You understand? You are the one that is going to be talking about LLMs. You are going to be talking about building models, artificial neural network, convolutional neural network. You want to know all the algorithms, which one are you going to use for that, blah, 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 and all that. Ladies and gentlemen, welcome to our own niche. Who is a data analyst? We focus on interpreting and driving insights from data through what various statistical computational techniques. Our job now to use the tools that have been developed by the what? The whole engineers have developed the infrastructure, the data analysts have developed the algorithm, and they've given us the software tools like Excel, Power BI, and Tableau. So, ladies and gentlemen, your job is to use the tools, get the data, plug into the tools, tear down the data, and tearing down the data and blah, blah, blah involves a lot. So I am going to share this particular area. I don't want to go through it because I've done the research. I want to help because this is a webinar. You have to leave this webinar understanding who is a data analyst, who is a data scientist, and who is a data engineer. Okay? Yeah. So this is a Venn diagram. You can see what do you need as a data analyst, data communication, and the tools. What do you need as a data engineer? You have to be a software engineer. Then, Baba, you need what? Math statistics algorithm. At the end of the day, you can see the data scientist in the middle, right? So somehow, you need to understand math somehow. You can see in the software engineering aspect, coming toward the side of data analysts, we are not there, we are dodging it, So that's the idea. But you can make a whole lot of money, by the way. Types of data analysis, let me talk about data analysis life cycle before I talk about the type. So as data analysts, I'm going to end by 7:30. All right, okay. Well, I still have some time. So maybe I will overshoot by 5. So I will use the remaining 30 minutes for question and answer. Of course, to equally talk about our training because of which we are doing this webinar. So I have gotten different schools of thought. These things are saying the same thing, by the way, if you look very deeply. But I want to take you people through it. What is a data analyst supposed to do? You are supposed to take data through the life cycle of data analysis. And what is the data analysis life cycle? So you can, I'm going to go through all of them, but they are saying the same thing, right? Now, I'm going to show you the similarity. You see, the first one says define. You start from define. Remember, we started talking about sampling from the beginning. Define, you collect, you clean, you analyze, you interpret. If you use software to do all these things, you are a data analyst, right? The second one, top there, say data acquisition, data preparation, data analytics model, and model deployment. It is similar, but they've changed the identify and collect to acquisition. You can see. If you go to the other one, say data generation, data acquisition, data storage, data analytics, and data visualization. The same thing. The one in the middle here, say data generation that flows down this way. Can I annotate this thing? Okay, yeah. So I can. So this one is saying data generation. It goes to data collection and storage, data analysis, data extraction, presentation. Okay. This one is saying problem identification, data collection, data cleaning, data analysis, data interpretation. Okay. Coming here, say business question, get data, explore data, prepare data, analyze data, and what present data. This one is saying data extraction, data preparation, data exploration, data visualization and reporting, data extraction, data transformation, data loading, data analysis, and data visualization. So let me just summarize this thing. Anything that has to do with the source of the data, okay, is the beginning of the life cycle of that data. Whether you're asking questions or identifying or gathering, it's the same thing. They are saying the same thing. You need to have a source of the data you want to analyze. It will be provided by your client. You can go for it by yourself. You can own a company and you are the one that actually wants to analyze data. You can actually be a researcher and you are gathering the data yourself. There has to be data in the first place. Second thing that you realize here is that there has to be cleaning, preparation. So some people use cleaning. Some of the schools of thought is using preparation, transformation. There's what they call ETL. We are going to do that in Power Query. We're going to use Power Query to do ETL. ETL means extraction, transformation, transforming, and loading. Power Query is part of Excel and is one of the most powerful tools you can use to that. Then when it comes to analyzing data and everything, we go to Tableau and we go to Power BI and example. So these are the things we are going to be doing in this data analysis class for those that will eventually come in. So the tools that are used for some of these things, Excel, number one. For us, there is SQL and of course there is Google Sheets. Please, I am having a scope. This thing is cumbersome. It can be confusing and we are taking a specific area because sometimes, oh boy, when you go online now, flyers everywhere, data, me, na Excel, two, Tableau and Power BI. If you are looking for anything more than this, go and look for. It is out of experience that we have chosen this and we are going to focus on it. You don't need to do everything to make money. All you need to do is be focused, learn it very, very well, and go for the money and give the client what do you want. You say, I say, if you must use it, then go and find your customer. I'm going to give you exactly what you want. These tools are enough. I can tell you that because one of the things we need to help people to do in this age and time is to help people to narrow down their thoughts. It's overwhelming. Information out there is overwhelming. That is why KodeHauz, for instance, we have separated Python. Yes, we have data analysis for Python. Go and do that one. You are going to do machine learning and everything. You see, Python is here. I am not touching it. The person that is even taking Python is on this call as well. So we need to help people to specify and be firm and have confidence in what they are doing and go for it. So we are going to be having data analysis. We are going to be having data analysis for Excel, Tableau, and Power BI. Okay. You need to learn how to collect data, visualize data with Excel, create interactive dashboard with Tableau, and build dynamic reports with Power BI. This is what we are promising. We are not promising any other thing, no. Like I said, we have to make it clear, who can sign up? Yes, a business professional can sign up for it, a data analyst can sign up for it, Power BI developer can sign up for it, data scientists can sign up for it, academic researchers, IT professionals, entrepreneurs can sign up for it. It's totally virtual, right? That's what we are going to do. And we are going to take you through 6 weeks I don't want to do so much because these things can be overwhelming. I'm not saying it's analysis because the last time I promised you have to extend it. Okay, you need to get data, explore it, prepare it, analyze it, and do the finding. You know, the course is designed to equip participants with essential data analysis skill using industry standard tools like Microsoft Excel. I've studied it. In that Excel, I'm going to talk about power. There's what they call power tools. Power Query, Power Pivot, and Power BI. And Tableau is another software that can equally do what Power BI can do as well. Participants will learn to gather clean. You see, this is what we are promising specific things because we are going to be doing project on this thing so that I can go and give the services where it is needed. You are going to gather, you are going to clean, you are going to transfer, you are going to analyze, you are going to visualize data to drive actionable insights. The course combines theoretical concepts. Yes, of course, if you are in this course, you know that I'm a theory guy also. I am not click, 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 click. So in between the courses, I'm going to be explaining some concepts so that you don't just be walking around the whole thing, you know. The course combines theoretical concepts and hands-on exercises, enabling participants to apply their skill in real world. Every data we are going to go to World Bank to get data. We are going to go to disease control to get data. We are going to get data, very difficult data. We are going to tell you. You are going to get the real world data. We are going. That's what we are going to be using to analyze it. So at the end of the day, if you follow through that life cycle, what you have on the left looks like what you are going to be getting. What you have on the left looks like what you are going to be getting. What you have on the right looks like where I want you to get to. Because this numbers does not make any sense until a data analysis makes sense out of the number. So guys, the learning objective is use Microsoft Excel for data analysis, including advanced formulas, pivot tables, and some form of automation. Transform and clean data efficiently with Power Query. Remember, I said ETL, extract, transform, and load. Build robust data model and perform advanced calculation using Power Pivot DAX. DAX is a language, okay? They call it data analysis expressions, right? That's what expression, that X is for expression. So design interactive dashboard and visualization. Power BI is powerful. I can tell you. In fact, you can end this course and just specialize in Power BI and start finding work. That's the truth. Okay, very, very powerful. Create compelling visualization stories in Tableau. Tableau is another powerful tool also that you need to know, especially for those that are, they have their own tech stack, and some companies prefer Tableau. Solve real world problem, you are going to have a final project as well. Of course, I've talked about the target audience. So guys, that is it. This is 9:33. I don't know if I'm correct. Sorry, 7:33. If I'm correct, before 8 o'clock, like promised, we should be done, and we respect people's time, and allow everybody to go and have a thank God it's Friday outing. Thank you very much. Once again, my name is Lawrence. I'm going to be the anchor for the data analysis using Excel, Power BI, and Tableau. Thank you.